Across the vast western plains of India, where summer temperatures scorch the land, rivers disappear into dust, and agriculture has always depended on the mercy of monsoon rains, engineers undertook one of the most ambitious water management projects in human history. They decided not to wait for rain, not to accept drought, and not to surrender to geography. Instead, they chose to redirect a mighty river, lift its waters, and spread them across some of the driest regions of the subcontinent through a canal system so large it can be seen from space. This is the story of the Sardar Sarovar Canal Network, a vast artificial lifeline designed to transform arid land into productive farmland and secure water for millions of people. The problem: too much water, too little access. India is home to some of the world's largest rivers, yet water scarcity has always defined life for millions. While eastern and central regions receive heavy rainfall, western India, particularly Gujarat and Rajasthan, remains brutally dry. Entire regions depend on seasonal monsoons that arrive late, fail entirely, or flood destructively before vanishing. For generations, farmers lived under constant uncertainty. Crops failed without warning. Wells dried up. Entire villages were abandoned when drought persisted for too long. At the same time, enormous volumes of water flowed unused through the Narmada River, eventually draining into the Arabian Sea. The imbalance was impossible to ignore. Engineers and planners reached a bold conclusion. The problem was not water scarcity, it was water distribution. The vision: harnessing the Narmada. The Narmada River is one of India's largest west-flowing rivers, cutting through central India before emptying into the sea. Unlike monsoon-fed streams, it carries water year-round, making it an ideal candidate for large-scale irrigation and drinking water supply. The plan was revolutionary in scale. Build a massive dam on the Narmada, store water during monsoon seasons, then distribute it across thousands of kilometers through a carefully engineered canal network reaching deep into dry regions. At the heart of this vision stood the Sardar Sarovar Dam. The dam, foundation of the network. Rising more than 160 meters above the riverbed, the Sardar Sarovar Dam is one of the tallest concrete gravity dams in the world. Its primary role is not just power generation, but water regulation on a continental scale. Behind the dam lies a vast reservoir capable of holding billions of cubic meters of water. From this reservoir, water enters the main canal, the backbone of the entire distribution system. But building the dam was only the beginning. The real challenge lay in moving that water across hundreds of kilometers of uneven, hostile terrain. The main canal, a man-made river, the Sardar Sarovar. Main Canal stretches over 450 kilometers, making it one of the longest irrigation canals ever constructed. Its width rivals that of natural rivers, and its flow capacity is engineered to deliver massive volumes of water without erosion or overflow. Constructing this canal meant cutting through rocky plateaus, sandy deserts, and densely populated regions. Millions of cubic meters of earth were excavated. Bulldozers, excavators, and concrete mixers operated continuously under extreme heat. The canal's slope had to be controlled with extraordinary precision. Too steep, and water would erode the banks. Too shallow, and flow would stagnate. Survey teams used laser-guided instruments to maintain exact gradients across vast distances. This was not simply digging a trench, it was engineering a controlled hydraulic system. Lining the canal, preventing the desert from drinking it. In arid regions, soil absorbs water rapidly. An unlined canal would lose massive volumes before reaching its destination. To prevent this, engineers lined the canal with concrete slabs, forming a continuous waterproof barrier. Expansion joints were carefully designed to handle temperature changes that could crack the lining under the intense Indian sun. In weaker soil zones, additional reinforcement layers were added beneath the concrete to prevent settlement and collapse. Every kilometer was inspected, tested, and corrected before water was allowed to flow. The desert would not be allowed to steal this water. Branch canals, spreading life outward. From the main canal, water flows into hundreds of branch canals, and from there into thousands of smaller distributaries. Together, they form a vast network stretching over 75,000 kilometers. longer than Earth's circumference. These channels deliver water directly to farmland, villages, and towns. In regions that had never seen irrigation before, farmers gained access to a stable, predictable water supply for the first time in their lives. Crops that once failed repeatedly could now be planted with confidence. Multiple growing seasons became possible. Agriculture shifted from survival to sustainability. Lift irrigation, pushing water uphill. Not all land lies below the canal. In many regions, water had to be lifted uphill using massive pumping stations. These stations house powerful electric pumps capable of moving water vertically over long distances. They operate continuously during irrigation seasons, pushing water into elevated regions that gravity alone could never reach. This lift-based irrigation turned previously unreachable land into viable farmland, expanding the project's impact far beyond what natural flow would allow. Crossing obstacles, roads, rivers, and cities. A canal network this large cannot simply cut through everything in its path. Where the canal intersects rivers, engineers built aqueducts that carry canal water above natural streams. Where roads and railways cross the canal, bridges and siphons were constructed to maintain transportation networks. In urban areas, the canal was rerouted underground or reinforced with protective structures. Every intersection required a custom solution, designed, tested, and built specifically for local conditions. The first flow, when the desert turned green. When water was finally released into the canal network, the change was immediate and visible. Dry soil darkened, dust settled. Fields that had lain barren for generations began producing crops. Farmers who once depended entirely on rainfall planted confidently. Villages gained access to drinking water. Migration slowed as livelihoods stabilized. From satellite images, the transformation is striking. Green corridors cutting through brown landscapes, a visible imprint of engineering on geography itself. The impact beyond agriculture. The Sardar Sarovar Canal network now provides reliable irrigation for millions of acres, drinking water to thousands of villages, support for industry and power generation, economic stability in drought-prone regions. The project reshaped not only land, but lives. Entire regions transition from water scarcity to water security. Controversy and complexity. The project was not without controversy. Environmental concerns, displacement of communities, and ecological impacts sparked decades of debate. Yet from an engineering perspective, the canal network stands as one of the largest and most complex water distribution systems ever created. A demonstration of what coordinated infrastructure can achieve at national scale. Engineering against uncertainty. Water management is not about conquering nature. It is about working with it, storing, guiding, and distributing it carefully. The Sardar Sarovar Canal Network represents decades of planning, construction, adjustment, and persistence. It is not perfect, but it is powerful. So now you've seen how India built one of the world's largest irrigation canal networks, transforming dry land into productive farmland by redirecting a mighty river across thousands of kilometers. Do you believe megawater projects like this are essential for the future of growing nations? Let me know your thoughts, and join me for the next story of human engineering reshaping the world.